But our topic today, to kick off, is the future of STEM and vocational education. Obviously, have a number of fantastic guests on this panel up here with me. I'm wondering if we can start. I'll start immediately with Tim Milkins, who's right on my side. Tim, would you like to introduce yourself? Maybe give us a little bit about what you do, and what's probably let's say the coolest thing that you've done in STEM. I certainly know your robotics program is very, very highly regarded, because all the schools that I work with always mention your school as the school they try to beat. You're the benchmark. I don't know if you know that.
Look, we do try to share. So, look, I'm Tim Milkins. I'm an educator. I work in a K-12 school up in Sydney's north, which is Barker College, if you know the school. My role in the school, I look after various aspects. It's going to seem quite different, a bit bipolar in some regards, but one half of my job is teacher accreditation and quality teaching in that space. The other half of my job is techniques innovation, which opens right out into what is the implementation of all of what we're talking about today into curriculum, into the co-curricular programs. And then I'm also involved in associations outside of the school that help me to facilitate that and reach further, not just to within my school, but within a range of different school environments. Coolest thing I've done at a STEM level, ironically, look, I am fortunate to run to be a co-leader in an incredibly successful robotics and mechatronics program. But I reckon the coolest thing was actually to implement and design a STEM curriculum that has been taught and works within the school, where students have really extended their work from year 9 and 10 to be these most amazing science extension and sometimes ISEF competition winning programs. One that comes to mind was one of the students, a lovely young lady, incredibly passionate about hockey, designed a data collector. That sounds really interesting, but when you consider she created a skull, her whole passion was about hockey, and her data collector was exploring the impact and the concussion risks on a human head if you were hit by a hockey ball or a hockey puck in the game. So when you start to consider that, she designed a device that tested about 5 different common helmets that are used within games. It was phenomenal. Again, we've done all these other things we've done significant risk assessments for, but again, that comes with science instead.
Look, do you know what? Even you just have that application of learning there. That goes straight to the coolest thing. And I heard earlier you had the question there about AI and what's its place and all that sort of stuff at the tail end of your talk. But I guess that's the whole thing is in education we have content, we have curriculum, we have learnings. But how does that apply to the real world? How can I take that and apply that to potential careers, potential pathways? And that's actually the whole crux. So here you have someone with their passion, investigating what their sport is, investigating potentially what like university degrees and what potential career pathways that might lay ahead for that particular lady. Now, Heather Catchpole is slightly further down from the man in the beautiful mauve suit. Heather, would you like to tell us again, similar, what do you do with your work, and what's the coolest thing that you've worked on in that STEM field?
So yeah, I'm Heather Catchpole. It's lovely to be here. I never get sick of hearing these stories about students' work in STEM and just how incredibly awesome it is, and sharing these teacher-educator stories. I'm from Questacon Educator Programs, so for the last 18 months I've been setting up a program called the Questacon Regional Leaders. We have one person in each state that work with educators to make those connections to industry, to have networking meetings, to have communities in practice and develop and share these kind of cool stories, which I just think is so valuable. And I have been going to these conferences for about 15 years in this role and in my previous role. And I have to say that the passion and the collaboration that happens here is just something really not to take for granted. I've done many cool things being in the STEM education space in the last 15 years. I worked to set up the Cruise of STEM, which you'll find over in the other room there, which is a careers hub for students, and that's been going for 12 or 13 years now. And I do think that careers connection is still really important. We can see the massive change that's happened, the transformational change and the challenge that it is to kind of keep up with this in the teaching world. As part of that, I got to go to the US. We got to launch the careers program there and just see how similar the challenges are, particularly in getting to low socioeconomic groups, and to see that how that, I actually came up from Tasmania to this, so forgive me if I die of heat today. But I can see personally those low socioeconomic kind of cycles happening. And I think again, I'm just going to throw out there now, we need to bring community along with us in what we do. I hope that amazing girl went home and shared with her parents just how awesome she'd been and what she'd done, and I hope that local industry took note. I think it's really important to kind of build that and share that community.
I'm the Director of Vocational Education for Western Sydney University. But I come I have a very big background, been in TAFE New South Wales for 25 years. And I've also worked for Digital Skills Organisation as the Chief Innovation Officer, where actually I got the opportunity where someone actually, that's where government throws money at you to pilot and do cool things, which I really enjoy doing. So what's the coolest thing that I've done? I think I went and sat with STEM employers and talked to them and asked them what they wanted. As you know, Western Sydney International Airport will be opening next year. With that is going to come a lot of opportunities. So through the Advanced Manufacturing Research Facility, we actually went in there and spoke to advanced manufacturing employers about doing an advanced manufacturing leadership scale-up program. And if they're going to scale their manufacturing into STEM technologies, then what's the upskilling program should look like. And that was just quite interesting because we combined this design thinking with generative AI. And Gen AI gave us quite a lot of data-driven personalization, not emotional intelligence personalization. So just to combine humans with these technologies and come up with a solution. So we are about to launch this workshop series for advanced manufacturing workers. And it's going to be facilitated by a human skills expert. Thank you.
Well, I'm a massive space fan, so if there's a ticket, I'll make sure I sign up. So my name's Andy. I work for BlueScope Steel, so just down the road here at Port Kembla Steelworks. Been there for about 15 years and have worked around both STEM and early careers for the majority of my career at BlueScope. My role at the moment is to look after what we're doing from an early careers point of view across Australia, not just here in Port Kembla. If you've sort of had a look at the news and seen some of the capital projects that BlueScope has invested in over the last couple of years, there's about $2 billion worth of investment happening both here in the Illawarra and New South Wales. So my role sort of came about because we're going to need a lot of STEM professionals to help build those projects as well as make our operations run. So my role is really to engage with education, government agencies to make sure that STEM careers are realistic in terms of what the students are looking for and inspire them to keep going from a STEM point of view. One of the coolest things I think I've been a part of in my role is I've been part of the early formations and ongoing steering committee of the Illawarra Academy of STEM Excellence here in the Illawarra. That's given industry a reach into schools that I don't think we've had previously, and it's given us a really coordinated approach and helped us build our networks with schools' point of view. So that's a really cool thing for me to be part of.
I deliberately asked the question of what's the coolest thing that you have done in STEM, because my next question, or the question that sort of Fred sort of set up as our first question is, what's the one part of STEM that we need to let go of? What's that outdated practice, or what's the outdated sort of, I guess, idea or concept in career pathways in STEM that maybe we need to release so that we can change and improve on moving forward?
I've got the mic, so
Yeah.
I can jump in. I would be interested to ask people here if they thought that they were ready to let go of anything from STEM, because I think, you know, and if we're talking from a school perspective, do you feel like you're doing a good job in STEM? Do you feel like you have enough time for STEM? Do you feel like you can teach STEM given the way that the curriculum works in a siloed approach? I don't know that we're ready to give up on STEM, because I think we're still partway through the journey. And I think this is part of the issue, is we've had 10 years or so of focus on STEM. And there's been a sense of, well, we haven't really got there, it's not, you know, now we need to transform, AI is happening, this is happening. I think we need to still focus on getting STEM in schools right. I think there needs to be space for it. I think there needs to be curriculum time to teach cross-curriculum. I think you need to give teachers space in the curriculum to teach STEM. How is STEM taught? As an elective, often?
As an educator, if I'm looking with a different angle, I just think that teaching STEM, you need to not treat it like teaching tools. It needs to be transferable capability that we need to focus on when you actually look at STEM, rather than, because if you actually think about AI that we would have taught 10 years ago, if we could do it as a tool, or we could do it as a transferable capability. Because if they have that transferable skills that they can engage using any of the tools, then they will be ready when they go out into the workforce, because the tools have changed. But their capability to absorb the tools, their capability to engage with the tools, adapt, engage with it as the tools adapt, will be there. So I'm kind of saying, with TAFE, I had a project where we introduced HoloLens, if you remember, VR headsets for work health and safety training. I think I had some colleagues from TAFE here. In the end, what happened was that even the people who were developing the program was focusing on, they were mesmerized with HoloLens rather than WHS, because it became a distraction. So we kind of need to focus on the learning still, and that means not teaching the tool, that means learning for the
Yeah, the tool, not the concept, because the tool is redundant within 6 months, whereas the concept is there for a lifetime. Andy, I've got a question. I think probably I'll start with you, but Tim, feel free to come in here too, because you mentioned there a bit about career readiness and career pathways, and as a representative from the industry, how do we help graduates from high school, graduates from high school, from university? How do we help them make sure they are ready to enter the workforce, that they are career ready? Is it with formal study, or is micro-credentialing? What's the role of micro-credentialing from an industry perspective? And Tim, even like then as a follow-up from your perspective, from a school thing, where does micro-credentialing and career pathways and graduate ready for employment, how does that look from a school thing? Andy?
So I guess in terms of a graduate point of view, we really believe in work integrated learning. So at a university point of view, we've got a cadet program that we've been running since the university started here in Wollongong, so for 50 years. So it's a cadet program where essentially students study 4 days a week they come to work 4 days a week and study 1 day a week. So that it extends the amount of time that they're doing their study, so they're studying part-time. But you know, we only have a certain number of positions that we can accommodate from supervision point of view, from that point of view. So where there is possibility to integrate work into that learning is how we see that. So where there's vacation student programs, internships with industry, those sort of things. So getting the student to actually come into industry at a university level, I think is as well in the future, if I can think about from a workforce planning and a futurist point of view, I think, in terms of letting stuff go, I think I still talk to students and parents from a school point of view where there still is a very big divide between, no, I don't want my student to go to TAFE and do a trade, I want them to go to university. You know, if I think about my workforce, particularly from a trade point of view, like part of my job is to ensure that they continually learn once they finish their Cert 3. So within 6 years of leaving Year 10 or Year 12, the tradespeople that we have at the steelworks are diploma qualified. And then they can move into, we support them going into their degrees and those sort of things. If you look overseas, there's much more integration between the vocation and tertiary. And so looking at how we can do that better in Australia is, I think, what we need to focus on, and we've been actively trying to do that, particularly with TAFE New South Wales, with the Centre of Excellence, to look at, well, what are the qualifications and the skills that we need in the future from our industry. It's applied technologies, so our tradesperson of the future, not necessarily going to be swinging as many hammers, but they'll still need to learn and know how to do that from a base trade level point of view. But they're going to be looking at data screens and interpreting data from sensors to know where they need to deploy those asset management strategies. But at the moment, going from a TAFE or a vocation point of view through to university and the other way around is convoluted, and it's very much on the student to sort of navigate that.
So from a teaching perspective, and I want to swing right back to the very first question around STEM, what do we give up? It's actually about each subject in isolation, and it's about the integration, the assimilation. But it's also about context, because if we don't have the context, now every school, every student, the context will be different. That's one of those things that's front and foremost for me as an educator, is that every individual child has a very individual set of interests. And when you start to tap into that, you've got this, kind of like the idea of you're going fishing with the best bait in the planet. You get that student, you get that learner, even if it's me, and I want to do it. They want to engage. So when you look at that space of how do we shift that forwards and how do we make that ready for post-school, post-high school, it's how do we hook them into activities and learning experiences which they engage with in a tactility, an actual physical manner. They engage with it at a cognitive level, their brains are ticking. I'm so fortunate, as Brett mentioned and I said before, I'm fortunate to be involved with an incredibly successful robotics program. Now, yes, it's robotics. Yes, I'm dealing with mechatronic systems, but it's not actually the robotics which is what I enjoy the most. Yes, I get to nerd out and play with the most incredible toys that are like rocket ships. I believe I'm going to space frequently. It's more the other side, that what I see is engagement. I see students who are working at engineering level that exceeds second, third year university. We've had to open and make accessible to our students, our alumni, our year 13, 14, 15 students, our workshops, so that they can come back and work, because the unis won't let them have access to a workshop, so that they engage, so that they extend. If I look at the other things, we're looking at micro-credentialing in systems like intralogistical robotics. Without the nerd term, stuff like warehouse robots, stuff that produces food, stuff that is automated. We're looking at bringing that into our facility and actually having our students from as young as year 9 and 10 gaining micro-credentials in operational and managerial aspects and programming aspects of these types of robot systems. We lift this a little bit further. Now I'm going to go about the skills space, not just the idea of what's STEM, but now we need to deal with the softer side of skills. So I spent a lot of years previously doing extensive research into which of the skills is, I suppose, the best values exchange in regards to what it is. And I'd say that there is no single skill, there is no single practical attribute that exists without communication. So we emphasise that space. How do we get them to communicate? I was going to say, sort of dovetail on the back of what Kath said earlier, to create and to problem solve without constraint. So just by taking that piece alone, it's the other idea of how do you get into the mindset. And I'll actually challenge, a lot of people say young brains are more limited in what they can project. I'd argue that they are less inhibited by the constraints of society and prior knowledge. So for that factor alone, let them dream, let them create, and let them make.